Hey guys, we're still on Unit 5, Stoichiometry and Moles. This is Lesson 5, Types of Chemical Reactions. Objectives for this lesson will be to identify the 4 types of chemical reactions: single replacement, also known as substitution, double replacement, synthesis, and decomposition, by just looking at reactants and products in a chemical equation. So let's start off with a warm-up. And you're going to balance the following equation using the lowest possible coefficients. So this is going back to lesson 4, and if you're not sure, go back to that lesson 4 and try to look at some examples that I've done. So pause the video, set it up, balance your equation, and then come back to the video to check your answer. Okay, ready for the reveal. Dun dun dun. Coefficients are 1, 3, 2, and 3. So as I had stated in video lesson 4, you don't always have to put the 1, but the Regents does like to see that you put the 1 in front to know that there is a coefficient, just one of those compounds. Okay, so let's start with our notes. Let's look at types of chemical reactions here. The first 2 we're going to look at, very simple: single replacement and double replacement. So single replacement by definition is a reaction where one species replaces another, one species alone on one side and combined on the other. So here's an example. What do I mean by this? 3 silvers plus a gold chloride will yield or produce 3 moles of silver chloride and gold. So notice, okay, one species alone on one side, and now it's combined with something from here, and now the gold is alone on the other side, the product side. So let's look at the next one. We have 2 chromiums, 3 sulfuric acids. So what's going to happen is the chromium by itself is now going to substitute with the hydrogen and pair up with the sulfate ion, okay, to create chromium sulfate. And then 3 moles of hydrogen gas. The hydrogen is by itself. Again, let's look at another example here. Chromium will then pair up with the second element or polyatomic ion in the compound that it is reacting with. Okay, so in this case, carbonate. So then it becomes chromium carbonate and 3 moles of iron by itself. So notice, one thing is substituting for another, and something different will be alone on the product side. So this will look like, a general formula will look like A plus BC, meaning 2 different elements, or a polyatomic ion in another element, so a compound, will yield AC plus B. General formula, okay? A not standing for any type of element, of course, guys. Okay, so again, general formula, this is like X plus Y equals Z, something like that. All right, so let's look at type 2. That's double replacement. So if this is single replacement, double is going to involve two switches, okay, or 2 replacements here. So the definition is a reaction where compounds react, switch partners, and produce 2 new compounds. So let's look at some examples here. Lead nitrate and 2 sodium chlorides. Okay, what's going to happen is the sodium is going to pair up with the chlorine over here, and the nitrate, the sodium is actually going to pair up with the nitrate this way. So you have an arrow going this way and one going this way, indicates double replacement. Let's look at our products now. So you have A, D, and BC. All right, so if we were to label this AB plus CD. Okay, so that's going to be the general formula for a double replacement. So let's look at another example. Sodium, okay, is going to pair up with the nitrate. Silver pairs up with the phosphate, and it's considered double replacement. We have this very long chemical equation here, another indicator that there's a double replacement. So if you look at your products and see that there's a switch of 2 different things to create 2 new compounds, then you have a double replacement reaction. So again, we see the general formula, AB plus CD is going to yield AD plus BC. Okay, last example, and I'm going to do it this way. Potassium pairs up with the nitrate, silver pairs up with the carbonate ion. Okay, remember ions are considered entities in themselves. Okay, you can't separate them. So any time you see more than two elements, then there is a polyatomic ion involved in that compound. Type 3 is synthesis. And what does synthesis mean? It means to make something, okay, or create something. So this reaction is where we take more than one reactant and create one product. So here are two examples. We have aluminum and oxygen to make aluminum oxide. The second example, we have hydrogen and oxygen to make water. Okay, notice two reactants to form one product. That is always going to be the formula to look at the reaction. So we have AB, A plus B will yield AB together. Those are probably going to be the easiest to identify. And then finally, decomposition. Decomposition means to break down. That's essentially what this reaction is doing. You have a reaction where we take one reactant, break it apart, create two new products. Okay, so let's look at some examples here. We have barium carbonate, which will break apart, and we end up with barium oxide and carbon dioxide. Okay, so virtually what happens is an oxygen goes with the barium and the other two will stay with the carbonate ion. Here we have 2 moles of hydrogen peroxide to break up into 2 moles of water and oxygen gas. And we also have 2 bismuth hydroxide to break up into bismuth oxide and 3 water molecules. So this is going to generally look like an AB to produce 2 new products, A plus B, okay, or create 2 products total. So when you go with one thing over here, notice, and now you have 2 plus 3, okay, if you want to number them, or we can use letters. A, B as a compound, now broken up into 2 different compounds or products. All right, so let's practice identifying some reaction types. Determine if the following are either synthesis, decomposition, single replacement, or double replacement. Using those general formulas, we're just going to look at our reactants and products. Remember, reactants with the beginning of the sentence, and then the products, the end of the sentence, basically the period. So we have one reactant here, okay? And what happens is we end up with 2 new ones, A plus B. So that pairs up with decomposition. And you can put a D to indicate that. Okay, let's look at the next one. We have silver nitrate and nickel. So now I see something alone, and I see something different alone on the right-hand side. So I'm automatically going to say to myself, well, one single thing, is changing spaces with something else. So this is going to be single replacement. Number 3, we have an AB here. We have one compound on the left, and I see 2 new things on the right-hand side, or 2 new products. So this is going to be decomp. Okay. Sorry about that, the parentheses. And let's look at number 4. Again, I can just tell by the, things that are going on here that this would probably be a decomposition. Okay, so again, I have an AB, and what's happening is I form 2 new products, A plus B. So now this is going to be decomposition again. So a new one, number 5, now I have 2 reactants to form only 1 product. So I'm creating something here. So that would be synthesis. I'm making a new product with 2 reactants. Number 6, calcium by itself and 2 hydrogen chlorides. Now if I look on the right-hand side, I see hydrogen by itself. So now I see something alone on both sides, and they are different things. So this would be a single replacement. Now, this looks very long, complicated. First indicator to me is going to be a double replacement because I see all this stuff going on. I see 2 products and 2 new products. Okay, they're not the same. I have calcium acetate and sodium carbonate Here I have calcium carbonate and sodium acetate. So what happened was the calcium went with the carbonate, the sodium went with the acetate to create two new products, 1 and 2. So now we can say that this is double replacement. This one generally likes to show up on the reagents, okay, these particular types of reactions, double replacement. So what I want you to do for the remainder of the lesson is to work on the rest of identifying reaction types on pages 19 and 20 of your homework packets. And also I'd like you to work on some of the balancing equations and determining types of reactions as well. You will see that in your packets. And we're finished.